So this is the first normal distribution question we've run into, because 2014 is when it was introduced. And as you know, most of your work is going to be done through your calculator, but the question is, what should you show me in the working to come up with these answers? And so I'll be focused more on what should go down here in your working versus typing in your calculator. You'll see what happens on the calculator as we go. But we have the January temperatures of Cairn is normally distributed, mean of 34, standard deviation of 3. So part A, calculate the probability of temperature of a random chosen date is less than 39. Now I'm going to do this down here, but I have that whole box. So for part A, this is work that's simple enough to show. And that is 34 degrees is the mean. You want the probability that temperature randomly chosen is less than 39. So you have 39 degrees over here. What's that probability? And so you can also, if you want, say the probability that X, which is the temperature, is less than 39, and that equaled, and on my calculator, I've worked that out. I'll give you a second to work that out, sorry. 0.952, which you can leave it like that or tell me it's 95%. The decimal answer is acceptable. So we find the normal distribution under the vars, so second vars to distributions, and we always will use the CDF. And we enter into our lower bound. Our lower bound, because this problem wants less than 39, we don't have a lower bound, but we do have an upper bound, which is the 39 degrees. And once we have that entered, we can enter into the calculator the mean, standard deviation, and let the calculator work that out for me. And once we've done that, we get the answer 0.9522, and the three significant figures, we have 0.952. But showing me some work, this drawing is an acceptable method. And again, if you make a mistake on the calculator, at least you've got a method point. And then part B, calculate the expected number of days that the temperature will be more than 39 degrees. Well, if 0.95 is the days that are less than that, then subtract that from 100, and that would be the percent of days more than that. And so there are 365 days in the year, and times that by because it's only 0.048 chance of it being greater than that, and from that we find out about 1.48 days that will be greater than 39 degrees C. So then to answer part C, which on a randomly chosen day in January, the probability that the temperature is above T is 0.7, or you can think 70% chance that it's above that temperature. Find the value of T, and you see I'm giving myself space to draw out what I want. And so again, there's my curve, there's my mean, and the probability that the temperature is above this is 70%. So pretty much, here's 50%, so it's above that, so being 70% is there. Actually, probably even, let's go a little farther. So this value T is the temperature at which 70% of all the other temperatures are greater, or all the days are greater than that. And so when I do my inverse norm, what I have to realize is my calculator works from left to right. So my calculator is going to be calculating this percent, and I want it to stop at 0.3. And so I plug that into my calculator. I'll be using the inverse norm, and I get that T is 32.4 degrees C. When you're giving the percent and you need to find the value, you'll be using the inverse norm of the normal distribution, and the area is the percent against that percent from the left to the right, so only 0.3. Insert the median standard deviation, and again calculate that the degrees is 32.42 to three significant figures 32.4.